So let's look at the part B. So what is a mature follicle? What are the function of thicker granulosa cells and cumulus ovaris? Cumulus ovaris. Okay, now this one is a structure of the Graafian follicle. It's a structure of the Graafian follicle. It's not the ova is here. Okay, we've already talked about the structure of the ova. But around the ova, this makes the Graafian follicle. So the ova is within the Graafian follicle. Okay, now what is thicker cells? Where are the thicker cells? Okay, these are the thicker cells here. So the thicker cells, they are the cells which are found in the outer layer of the follicle. They play a crucial role in the synthesis of androgens. Androgens, they are like testosterone, under the influence of LH, luteinizing hormone. So these androgens are then converted into estrogen by the granulosa cells. Okay. And then the granulosa cells, they are able to convert androgens from the thicker cells into estrogen under the influence of follicle stimulating hormone. Granulosa cells, they also secrete inhibin, which regulates follicle stimulating secretion. What about the cumulus ovaris? These cells play a critical role in oocyte maturation, nutrient supply, and facilitating sperm entry during fertilization. So I've mentioned some of the important cells within the Graafian follicle. So we have the thicker cells, we have the thicker externa and the thicker interna. Okay, these cells, they secrete what we call estrogen, androgens, under the influence of luteinizing hormone. But next to the thicker cells, we have the zona granulosas. These cells, they convert the androgens, which were produced by the thicker cells, into estrogen under the influence of a hormone called follicle stimulating hormone. Okay, this is where we find the aromatizing enzymes. Aromatizing enzymes help to convert androgens into estrogen. Okay, so just have a look at this. Now, describe the sequential development of the follicle and the formation of the corpus luteum. Describe the sequential development of the follicle and the formation of the corpus luteum. Okay, this one is straightforward. It's just trying you to appreciate how the follicles develop. Okay. So we have the primordial follicles there. They contain the primary oocyte or oocyte surrounded by a single layer of granulosa cells, as you can see there. And then we have the primary follicle there. The oocyte will enlarge and granulosa cells becomes cuboidal, beginning to proliferate. And then there'll be a formation of the zona pellucida, as you can see there, around the oocyte. After that, we have the secondary follicles which are formed. So the multiple layers of granulosa cells will form around the oocyte. And the thicker cells will also differentiate into thicker internal and external layers. And the follicle will begin to secrete estrogen. Remember, the thicker cells, they are producing androgens. And the granulosa cells, they are converting the androgens produced by the thicker cells into estrogen. So secondary follicles, we are going to see production of estrogen. And then we have the tertiary follicle, which is called antral follicle. Okay, this one is a fluid-filled cavity. It has a fluid-filled cavity called the antrum. This one here. It has a fluid-filled cavity called the antrum, and the follicle will continue to grow in size. And finally, we are going to have what we call the dominant follicle, or the Graafian follicle, before ovulation. That's why it's called the antral/pre-ovulatory dominant follicle, also called the mature follicle. So the antrum enlarges, and the cumulus ovarus forms, and the follicle reaches its maximum size, ready for ovulation. The ovulation will be under the trigger of a hormone called luteinizing hormone. Now, the other part of the objective says, and how is there formation of the corpus luteum? So after ovulation, the remnants of the Graafian follicles are going to transform into the corpus luteum under the influence of luteinizing hormone. Thereafter, the corpus luteum will begin to secrete progesterone and some estrogen, preparing the endometrium for possible implantation of a fertilized egg, in case that egg which has been released becomes fertilized. So we need to prepare the uterus for possible implantation. However, if fertilization does not occur, the corpus luteum is going to degenerate into the corpus albicans, and the hormone levels of progesterone will going to reduce, and then it's going to lead to menstruation.